Right, we now have a different method of solving quadratic equations. It's called completing the square. Now, this is rated at A star. It's not always that hard, it would seem. Now, let's do number 1. I'm given this. I'll show you what I mean by completing the square. I've got x squared plus 4x plus 1, and that equals x plus 2 squared, but I know if I multiply this out I won't get x squared plus 4x plus 1. I'm going to get x squared plus 4x plus 4, so minus a. Work out the value of a. Really easy, because if I was to multiply this little part out, I would get, like I said, x squared plus 4x plus 4 minus a. Now therefore a's got to be 3 to make this side equal to the right hand side. So therefore, by comparing both equations, I've got a equals 3. And I'll do the second one as well. I've got y squared minus 14y plus 8 equals, again, you see what I mean by completing the square? So that little bit is squared, but if I multiply it out I won't get what's in the original equation there. So I've got to add on or take away a little bit at the end, which completes that square to make it true for both sides of the equation. So busting this open, I'm going to get y squared minus 14y plus 49, because 7 sevens are 49. Now I want to get from 49, oh, plus a b by the way, I want to get from 49 down to 8. So what's b got to be? Well, from 49 down to 8, I better take away 41. So 49 take away 41 gives me 8. Therefore b equals minus 41. Most ugly? Right, let's do question, I don't know, question 5. I've got to complete the square. I've got to try and solve these things, but because I can't take it all the way, I've got to leave it in surd form. Now let's do number 5. I've got z squared plus 8z minus 2 equals 0. Let's just complete the square as far as we can. So to get 8 there, I'm going to need plus 4, aren't I? And then I'm going to square it. Now, z plus 4 squared, what's that going to give us? That's going to give us, just to test it out, z squared plus 8z plus 16. Alright? Now I want to go from 16 down to minus 2. So therefore I want z plus 4 squared. From 16 down to minus 2, I need to take away 18, don't I? And that equals 0. So I've just completed that square to make it equivalent to the original question. Now how do we begin to solve? Well, we'll take the 18 over next door. So z plus 4 all squared equals 18. Now of course if I then press the square root button on that, 18's, you know, a third. So here we go. I've got z plus 4 equals plus or minus the square root of 18. Now let's have a look at that. Can I break it down a little bit? I think I can actually, and that's going to equal to root 9 times root 2. So that's going to be 3 root 2, isn't it? And again it's going to be positive or negative. So what I've got left, I'm going to take my 4 over and subtract, and final answer, z is going to be plus or minus the square root of, plus or minus 3 lots of the square root of 2, 3 root 2, minus the 4. And that's quite complicated for, I shouldn't have done number 5 basically, but anyway, it's good enough. The thing was, the root 18 could have been simplified, and so I did. So root 9 root 2, that takes us back to chapter 4 I think on surds. Let's just do some more like that. That's quite involved. Let's do number 7, see what happens, then we'll take it a bit at a time. Right, p squared plus 12p plus 30 equals 0. Clearly I want to go p plus 6, so if I multiply that out, that's going to give me 12p's, isn't it? Now try and do this in one step. If I multiply it fully, I'm going to get p plus 12p plus 36. I want to get from 36 down to 30. Therefore, if I subtract 6, I complete that square. Let's get solving. So p plus 6 all squared equals, take the 6 over and add, and go 6 plus 6 by itself, I want to go plus or minus root 6, and root 6 can't be simplified. I'm very happy to leave it as is. So then we're going to take the 6 over and subtract. P equals plus or minus root 6 minus 6, and that's the end of that. Quite easy. To do question 10, it's got here v squared plus 22 equals 20v. Bring it all over to one side. V squared minus 20v plus 22 equals nothing at all. Now, in order to get minus 20v, I want v minus 10. Meant to be a nice little pointy v. There you go. Now, that will give us minus 20v. 10 tens are 100, even though they're negative. So I need to take away 78 to complete that square. Now, trust me on this one. That's going to be, take the minus 78 over, it's going to be plus or minus the square root of 78. Now, the root 78 can't be simplified. I've tried all sorts of square numbers, nothing works. So I'm going to leave it like that and say v is going to be plus or minus root 78 plus 10, and that's the final solution. I'll do 12, it's the last one before it starts getting really silly. Completing the square, 3c squared minus 18c plus 3 equals 0. That's a bit of a giveaway, isn't it? Let's divide by 3 and make life easy. C squared minus 6c plus 1 equals nothing. Let's make it all nice and pretty. So c minus 3 would give me c squared minus 6c plus 9. How do you get from 9 down to 1? Take away 8, and that equals 0. Alright. Usual thing. C minus 3 squared is going to be 8. Now when you try and square root 8, that is a surd that can be simplified. So let's just do it. C minus 3 equals plus or minus the square root of 8, which means plus or minus square root of 4 times square root of 2. In other words, root 4 is of course 2, so it's plus or minus, make that prettier. That's going to be plus or minus 2 root 2, and then we're going to take away the take away the 3 later, or add the 3 rather. Therefore, C equals plus or minus 2 root 2 add 3, and that's the solution to that one. That's question 12 done. Now over the page, what we got? 13. And let's just try this. I've got here, you're given this identity. Please note the word identity. So x squared plus something x, mx plus 25 is identical to, please note that sign there, it's identical to or equivalent to x plus something n squared. Very complicated, but I do know if I try and complete this square, I'm going to have an x there plus 5. I know that because x times x gives me x squared, and 5 5s are 25. Right then, so, and that is a perfect square obviously. Now if I break this open, I'm going to have x squared plus 10x plus 25. So straight away by comparison, I've got the m links in with the 10 there, because that's the coefficient of x, so m equals 10. And since I've completed the square, and it's a perfect square anyway, I can compare n and 5, therefore n equals 5. Alright, bit of an unusual one that, but it's okay. Try another one. This is 14. I've got x, didn't do that well, did I? Do it again. X squared minus px plus 121. That's 11 times 11. I bet I'm going to need that. Is equivalent to x plus mystery q squared. It's the same sort of thing. It looks like a perfect square to me. So in order to get plus 121, but with a negative value there, I'm going to go with minus 11 and square it. Now let's bust this open. So straight away, if I break this up, I'm going to get to x squared minus 22 x's plus 121. Is that alright? Would it work if it was plus 11? Well, it might. Let's just read the question again. Work out the values of p and q. So if that was plus 11, it will be plus 22x instead, wouldn't it? But let me just run with this and see where we go with it. So by comparing coefficients, I've got minus p is minus 22, therefore p is 22, and by comparing the coefficients, well, not coefficients, by looking at the at the bracket q is minus 11, and q equals minus 11. What I'm going to do now is pause this video and consider what would have happened had I gone for plus 11. Right, I've considered what would happen if I did this. This is also a perfect square. Look at this. X plus 11 squared is perfect and will still give me 121 on the outside. If I multiply this out, I will get x squared plus 22x's plus 121. And by comparison, I've got 22 links with minus p. So minus p equals 22. Therefore, p equals minus 22. One solution. And also by looking at the bracket, I've got 11 is q, and therefore q is 11. Therefore, there's two sets of answers depending on how I build up, on how I arrange the perfect square. X minus 11 all squared will give me one set of answers. P is 22 and q is minus 11. And arranging the perfect square as x plus 11 squared, still a perfect square, I'm going to get p is minus 22 and q is itself, and q is itself 11, not minus 11. So I'm going to run with that, and I'm happy with it. So that's that. Now, what else is there? We've got question 15 with a great big dangerous asterisk by it. Anyway, so I've got here 4x squared plus 12x plus 3 is equivalent to 2x plus a squared plus a dangly bit called b. Alright, great. So let's just begin to do this little bit. Now, if I put this in a bracket like so, plus something squared plus a dangly bit, I'm going to work out a dangly bit in a minute. Now, how am I going to end up with 12x's? If I put a 3 there, I go 4x squared, just multiply out to prove it to you. I go 2x plus 3 with 2x plus 3. Is that alright? Break it all open. 4x squared, u and u, plus 6x, plus u and u, 6x, 3 times 3 is 9. So what have I got? I've got 4x squared, 12x, 9. So let's take care of that and that. So they're looked after. So I want to go from 9 down to 3. Therefore I take away 6. So let's go back to my perfect square and take away 6 to complete it in order to go from plus 9 down to plus 3. So now I can compare what I've got. I've got a equals 3, and there's my a equivalent, and I've got b equals minus 6 with that b there, and that was incredibly easy. And that's the last question, I suppose, and that's the end of it. Thank you.